My name is Stephanie Santangelo, and I'm going to talk about the empirical and molecular formulas. The empirical formula of a chemical compound is the simplest positive integer ratio of atoms present in a compound. The molecular formula gives the total number of atoms of each element in each molecule of a substance. So the tricks for finding the empirical and molecular formula are here in front of us. For the empirical formula, we're going to use the mass percent of the elements. We're going to assume an 100-gram sample, and we're going to find the grams of each element using the atomic weights of each element. We're going to find the moles of each element, and then we're going to find molar ratio of each element to form the empirical formula. Once we've determined the empirical formula, we can then determine its mass, and then determine how many times greater the molecular mass is compared to the mass of the empirical formula. We are then going to multiply the empirical formula by this number in order to get our molecular formula. So this is a practice problem. The problem is a compound is 75.46% carbon, 4.43% hydrogen, and 20.10% oxygen. It has a molecular weight of 318.31 grams per mole, and the question is asking what is the molecular formula. So first we're going to start by getting the mass of each element by assuming a certain overall mass for the sample of 100 grams. So we're going to do this by multiplying these percentages. 4, 6. So this is for the grams of carbon. So this is going to equal 75.46 grams of carbon by multiplying that percent composition by 100 grams. And then we can do the same for the hydrogen. Times 100 grams, and that's going to come out to 4.43 grams of hydrogen. And then lastly, we're going to do this for the oxygen. All right, after we converted to grams using the percent composition and the 100 grams, we found the mass of each element and we changed it to moles. And now we're going to have to find the ratio of the moles of each element. So to do this, we're going to take the moles and we're going to divide it by how much we have. So I used the smallest amount of moles that we got from this step right here, which was the oxygen, and I divided each of the moles that we had from each element by that number that we got from the oxygen to get the moles over here. And then we used these moles to create the empirical formula by multiplying the mole ratios by 2 to make them whole numbers. And when we do this, we're going to get an empirical formula of C10H7O2, as we multiplied each of these by 2. So once we have the empirical formula, our next step is going to be to find the mass of the empirical unit. So to do that, we're going to multiply those whole numbers that we got by the molecular mass, the molar mass, of each of the elements. So when we add these together, it's going to equal 159.06 grams per mole. And then our next step is going to be to figure out how many empirical units are in a molecular unit. So we're going to take So this was the molecular mass that it gave us, and we're going to divide it by what we found. 6 grams per mole, and this is going to equal 2.001 empirical units per molecular unit. And then since there are 2 empirical units in a molecular unit, the molecular formula is going to be the empirical formula, but all the whole numbers multiplied by 2. So that's going to equal C20, H14, O4. And that's how you would find the empirical formula and the molecular formula from the empirical formula. Here are some practice problems above with the answers underneath them, so you can practice the skills that we just learned.